Dustin is going to present it for us. So welcome to him, and let's watch the talk.
Alrighty, so hello everybody. Today we're going to do a riveting anatomy of NTLM version 1 and NTLMv1-SSP. And how this talk came about, I should first go through the standard disclaimers. So I'm Evil Mog, I'm a shenanigator, I'm a Church of Wi-Fi bishop, I'm a doer of stuff, and I pretend to be on Team Hashcat once in a while. So, disclaimers. Big Blue sort of has knowledge of this talk. They neither endorse nor condone it. Opinions expressed are mine and mine alone, no warranty, express or implied. I'm not responsible if you burn down your house because of your Hashcat cluster. The code is not guaranteed to work, and I like to steal from Stack Exchange. My walkthroughs are sketchy at best. Please consult a qualified professional before attempting this on your own. This is not Python version 3 compatible. Do not send me a pull request to make it Python 3 compatible because I don't care. My code is terrible. I steal from Stack Exchange, and all the hard work was done by others. I just packaged it somewhat prettily. So, first of all, who here knows what an NTLM version 1 challenge is? Very few of us. Okay, so a lot of us use Responder on the network once in a while. And in order to break into a network, Responder tends to go extract hashes. NTLM version 1 was a challenge response format that would have been used a lot on Windows 2000, Windows XP, and occasionally we see it on networks. You'll see, it shows up as NTLM version 1 responder because it says NTLM version 1. Now, how this talk came about was I gave a talk at DerbyCon 2 years ago on this exact same subject, only it was missing a lot of critical information. In fact, I'm pretty sure Minga asked a couple of questions asking how I made this thing actually work. So, the gist of this is you can take an NTLM version 1 challenge and you can reverse it to NTLM without actually cracking the password, no matter the password length. Now, I got a little bit lazy, and I decided to code a tool so we can automate the heck out of this and then give some real information as to how we actually do this in the real world. So in this example, we're running Responder using Python responder.py, give an interface name, we use the tac-tac-lm field, -FWRP, and it comes back with this nice shiny little NTLM challenge. Now, if you don't use the --lm, it mangles the challenge and puts a whole whackload of zeros, which can't be used to pass directly into Hashcat. So what we're going to go through is what we're actually looking at when we talk about these challenges. So, one sec. Yeah, okay, so the anatomy of NTLM version 1 and version 1 SSP is the actual NTLM packet you get back for version 1. It's separated out into a number of fields. Field number 1 is going to be your username. In this case, it's Hashcat, which is right... If I had a pointer, I'd make this easier. But on our top line there, you'll see Hashcat, you'll see Dustin dash whatever, you'll see the NTLM or the landman response, and you will see the NT response along with a client challenge. So I got really, really lazy, and I decided to make a multi-tool to automate your use of automate things when you're pen testing. So basically, what we've got here is an NTLM multi-tool that will take an NTLM version 1 hash and output your challenge files that you need to pass to Hashcat for use with mode 14,000 and return the des keys that can be convertible into an NTLM hash. We also wrote a tool to deal with SSP. So when you don't use the --lm and you still need to reverse things, it calculates your server challenges for you correctly. And then because I'm really lazy and I need to verify my code actually worked, I kind of wrote a NTLM to des key calculator on the plane while I was drunk because I realized none of my code worked. So people make mistakes, so I made the tool to go validate my stuff was actually functioning. So in this case, we're going to walk through how this tool actually works. So we've extracted an NTLM without SSP hash, and that's this Hashcat Dustin 5A right at the top. You feed it into my tool using Python NTLM version 1, you use tac-tash no SSP, and you paste in the hash. What it does is it'll split out the hash into various fields for you. It'll tell you the username, or the host name, username, the challenge, landman response, NTLM, or the NT response, CT1, C2, CT3. You can ignore all that stuff. The important part is it will spit out, where was it here? There we go. Bear with me, I had redone my slides. So it goes further into telling you how to calculate the last 4 characters of an NTLM hash. Now, for those of you who haven't read Moxie Marlinspike's paper, where a lot of the stuff is derived from, An NTLM version 1 challenge is effectively 3 DES keys. Those 3 DES keys are made up of your NTLM hash. Now, because of a bunch of padding, the final 4 characters of the NTLM hash can be calculated in real time without brute forcing, using a tool that Adam wrote called CT3 to NTLM.bin. Now, a lot of people have been saying, well, how does this work because we see SSP? So I wrote some tooling that basically just gives you the commands to run from your Kali box. And so that's what this tool's output is. It's showing to calculate the last 4 characters, you type this command. So, for example, you want to go crack these NTLM keys. Part of the tool's output is make a hashcat challenge file with the first half of your CT1, your challenge, and then it outputs the hashcat command you want to go execute. Now this on a regular rig would take about 7 days to return at the most. In most cases about 3 on say an 8 GPU rig. But you can add things like skip and limit to split up across multiple nodes. So this is all the stuff from my previous talk that actually largely worked without any actual bugs. Where things came into problems was when you apply SSP, because the landman response starts getting overwritten with a whole bunch of zeros, and you have to go manually recalculate. So, for example, we're going to crack our hash, so I'm going to rewind this a little bit just to get back some theory. What you can do with this hashcat file is there's a des mode 14,000, which is basically a generic des cracker. What this cracker is basically you have the plain text and you have the ciphertext. So it's a known ciphertext attack. It derives the DES keys, which basically make up the NTLM challenge. So you can effectively grab NTLM version 1 and crack it with your GPUs or pass to crack.sh, grab the hash out and pass it around the network without ever knowing what the password was. So that's all this is effectively doing. So it automates a number of components. So it tells us, hey, like we've managed to crack these hashes. Now once you've got these challenges or this hash cracked, the DES keys it outputs in hashcat are not directly usable at all, period. What you need to do is you need to convert those into an NTLM key. Thankfully, Adam wrote a tool in Perl that I still to this day have no idea how it works because it looks like it's C-like Perl. And Jeremy gives me crap all the time because I'm a Python weenie instead of a Perl weenie, but friendly ribbing. So you crack this hash, you get your 2 DES keys out. It looks like 8923 BD in this ugly hex format. You run it through the Perl tool, it gives you 88, 46, 47 for your first half, your second half. You'd have your output from CT3 to NTLM.bin, gives you the final part. You have password. Fairly straightforward NTLM version returns that we've been doing for the last 2 years. This stuff is all known. The problem is when you have SSP involved. So during my testing, like I said, I couldn't get any of my code to work and I was on an airplane because things like SSP weren't operating. I didn't have access to my cluster at the time. So I had to go read up how it converts NTLM keys to DES. So I wrote a Python tool for that as well. So you can take an arbitrary NTLM hash, spit it through the tool, and it'll output the expected output from hashcat so you can verify that your tool chain's working when you're reversing NTLM version 1 to NTLM SSP. So it makes things a little easy. Now SSP, here's the part that we all actually care about. SSP will happen in most modern environments when you haven't used the --LM in responder. And quite often when you're trying to reverse NTLM version 1 to NTLM, and you'll paste your NT hash into crack.sh, for example, and it comes back with an uncrackable hash. The reason for this is the client challenge gets overwritten in SSP, or modified rather, with a combination of, I'll go into the code here in a second, actually, on my next slide. But basically it gets modified so you can't use this technique anymore. So if you use the 1122334455667788 client challenge, none of your stuff will reverse on the FPGAs, and you're kind of crap out of luck. So let's get into the actual code of this. If you look at an SSP hash, the first field on this is obviously the host name. Second field is going to be our username, or going to be blank. Third field's our username. The fourth is this this landman response with all these zeros. So what we're effectively doing is we are taking the client challenge and the first 16 characters of the landman response, combining them together, running those through MD5 to recalculate your server challenge and spit you out the actual values you need to feed into hashcat. And this does it all automatically now for you, so you don't need to calculate the stuff in your head or go pull it, some other dodgy scripts. I was searching around for tooling to do this, and I couldn't find anyone who's even doing tooling or even published how this actually worked until I found some random website from 2003 or 4 that was writing about it, and I had to go figure out how this code worked. So what you do is you take your Python, run it through, run my script, NTLMv1-SSP, use TAC-SSP, paste your NTLM version 1 response, and it'll spit out your landman response, your NT response, your client challenge, and your modified server challenge. It'll tell you how to crack the final 4 characters of the NTLM hash using CT3 to NTLM. In this case, it outputs the N58.6C. It spits out your hashcat challenge files for you. So you just make a file called hashes.txt, crack it with hashcat using hashcat-m14000, attack mode 3, character sets, des full character set with the -- hex character set, hashes.txt, and then your question 1 standard attack path format. And it tells you what to type in. So you just copy and paste this into your terminal, wait 7 days or 3 days or a day in my case with how much gear we're throwing at it. It gives you back your response in $hex. You run it through your Perl component to convert your des key to NTLM, and voila, we have ourselves an NTLM hash, because part 1's the 88, part 2 is that 17 AD, final part there is 58.6C, and we are good to go. So in summary, NTLM version 1 is broken. You should never ever use it, and if you do, you should feel bad. Number 2, NTLM version 1 can be reversed to NTLM hashes, and now we have tooling so you just copy and paste and hit a couple of buttons as opposed to manually reading all my white papers and how to do this and not understanding my terrible blog posts. The other important part, though, that people should care about is NTLM SSP will stop you from using the cracked.sh rainbow tables. You have to pay your $20 if you see SSP in play. So whenever possible, use --lm instead of static challenge of 1122334455667788 when you're a pen tester. The problem with this, and this is what kills everybody, is Semantic and a number of other AVs out there start picking up static client challenges, so you start getting popped left, right, and center. So the crack.sh rainbow tables aren't exactly working effectively. So that's why I wrote this tool. I got tired of dealing with this manually to make life easy. Now, my code is terrible. I do accept pull requests. Just please don't run automatic Python 3ifiers on my code because it messes with the bitwise math. I see one more pull request, I will track you down and initiate you into the Church of Wi-Fi. And that is effectively this rapid whirlwind talk. I apologize it was ultra quick and there's going to be tons of questions because I flew through this so fast. So I'm going to open it up to the floor.
Give a technical description of exactly what the LM flag does?
Yeah, absolutely. So the question was, can I give a technical description of what the --lm flag does? So in the original NTLM version 1 without SSP, there's a landman response portion and an NTLM response portion with the client hash. So your response is going to look like... Where am I here? That's a good no SSP, but let's get back to here. So your response is going to look like this. Again, you have your first field, and this is your hashcat. So it requests the NTLM response format using --lm in responder. So it gets you a complete hash, and it manages to not activate SSP. When you omit the --lm, it changes your response format to look like... Where's the one with SSP? I redid my slides. I brought the wrong slide deck, so I apologize. It looks like this. So when you omit the --lm, it basically zeroes out anything past the first 16 characters of your landman response. So you basically have to calculate out that missing data using to calculate a server challenge out. And that's what this basically does. This figured out how the server challenge is working effectively.
And how common do you see NTLM1 still enabled in environments?
Unfortunately, I see it about once a month. And I do, not once a month, but once a quarter. Typically, it's in environments that haven't turned off, like it used to be an XP environment or Windows 2000 environment, and they haven't turned off the GPO flag. So I've seen a Windows Server 2008 or 2012 R2 environment with Windows 7 still running NTLM version 1. Quite often, though, when they're running NTLM version 1, you really shouldn't be needing to go reverse to an NTLM, because quite often they'll have things like SMB relay enabled or other bigger problems. But I've had times when having to reverse an NTLM 1 back to NTLM actually works in production. Any other random questions to go heckle? Because I know this is ultra quick, and I apologize. Anyone else? Bueller? Everyone like my shiny little tool? Yes, you.
For Ntlm version 2, is that the way everything's being stored today? I haven't kept track.
Okay, so there's a little bit of misconception about NTLM, and I'm going to clarify it for this just because it's handy. With NTLM, you have NTLM, the password storage algorithm. Then you have two versions of a challenge response mechanism to go authenticate, along with Kerberos. So when people say NTLM version 1 or NTLM version 2, they're really talking about, hey, I'm a client, I'm talking to a server. And it's a way of exchanging the NTLM hash without actually exchanging the hash. So NTLM version 2, for example, is just part of the hash response component to it. A lot of places are going to Kerberos these days, for example, just to make things harder. But the actual storage algorithm is NTLM. And all NTLM is a UTF-16 encoded string run through MD4. And no matter what, whether you're using Kerberos or anything else, Windows will always store the NTLM password hash, which is broken back in the 90s, which is why it's so fast. It's actually faster than MD5. Anybody else? Questions? I'm sure there's got to be something. I've got plenty of time. Is anyone else? Sure.
I just feel just so lost with this stuff. We had the previous
with the previous talk, blacklisting in AD, and he was talking about SHA-1 hashes in AD, and then, so I'm confused with this.
Okay,
whole,
so AD doesn't actually use SHA-1 at all. Period. Active Directories will store two types of passwords stored in its database. The first one it stores is landman, which we've all disabled, or we should have. If you haven't, you should feel bad. That's what the rainbow table attacks work well on. Then there's NTLM, which is the newer one that was implemented in the 90s. Came out with NT4, if I remember correctly. And that's MD4 based. It's a UTF-16 encoded string. So it doesn't use SHA-1 in any way, shape, and or form. We're all based off MD4, effectively. Then you have, for challenges, you have NTLM version 1, NTLM version 2, Kerberos with MD5, aka MD5 HMAC, and then Kerberos with AES keys. And that's how Windows does its authentication today. Oh, and certificates.
So one follow-up question. So he was talking about how you're checking against bad passwords and you're downloading these tables, and most of these tables are hashed with SHA-1. That's why I'm confused. How is this?
So the reason why he's using SHA-1 is a certain individual that's known and famous, and I have no idea why, published all his tables in SHA-1. And there's a lot of garbage data in that data set. I'm not slinging any mud. I'm just saying there's a lot of garbage data in that data set. And so a lot of people in their breaches will do it in NTLM or in SHA-1. I see SHA-1, MD5, MD4. I mean, there's most of the things out there. There's a variety of storage mechanisms. The most popular one, to be honest, for years is MD5. But I have a funny feeling that the previous speaker used his format because you could do a direct API call and do a lookup against the Have I Been Pwned, which uses SHA-1.
One aspect of NTLM that I've encountered in environments is where the setting for the NTLM restrictions are different on domain controllers than they are on servers and clients.
Yes.
I recall there being a reason for that, but it's been years. Can you speak about that on a technical level?
Yeah, it's for compatibility reasons. The way it works is there's two settings you set to control NTLM in an environment. One is your client compatibility. The other one is your server compatibility. So say, for example, I'm upgrading to mandate NTLM or Kerberos across the board.
Oh, no, sorry. More specifically, domain controllers. Is there any legitimate reason you would have that setting differently on domain controllers?
It depends if you have old legacy clients that you can't quite get away from. So say, for example, you're an old terrible bank running Windows XP on your ATMs, or Windows CE, and they may or may not be able to control how things are operating, then your domain controllers you'd set for a better compatibility setting. But if across the board you're migrating everything off, then you do the change. Now, obviously, you have to watch out for things like printers, etc. Because once you change it to require, say, NTLM version 2 only and above, you have to make sure everything's compatible. So people will set their domain controllers to be the most compatible setting.
And now, do you see any risks in that in the real world?
I mean, I'll be honest, you shouldn't be using NTLM version 2 in the environment anymore. Just with the amount of GPU power we can throw at things. But implementing a pure Kerberos implementation with only AES keys is rather difficult and breaks a lot of clients. So the best compatible setting I've seen in enterprise is still NTLM version 2 and above. Version 1 should not be enabled, and if you still have stuff that runs it, you should be yelling at your suppliers.
Thank you.
Anybody else? Yeah, Minga. Here comes the roast.
Okay, I have a serious question and I have a heckle.
Okay.
Serious question first. The DES keys, have you ever done a large scale analysis of their randomness to see if there's any, I mean, are they pure, do they appear to be random? Is there any sort of, obviously not a pattern to the DES, but have you ever done anything like that?
The DES keys that we've noticed are purely correlated to the NTLM key. All it is that you take the NTLM key, and it basically, the NTLM mode is effectively a 56-bit key that you have to pad out to 64-bit to do your parity calculations. So that's what the NTLM to DES parity calculator is. So if you can find any patterns on the NTLM, then you can find the pattern in the DES.
Good answer. So now for my heckle. Were you implying that the big giant old ghetto bank that you used to work at uses NTLMv1 on their domain controllers?
We may have at one point. We changed it before I left.
Okay, you know you're on camera, right?
Yeah, I know.
Okay, just making sure.
Yeah, no, we changed that about 3 or 4 years ago before I left. And that bank wasn't that ghetto. It wasn't a real bank. It was a financial institution. Anybody else? I haven't seen you heckling from your cohort to your right there, or to your left. Does he want to heckle too?
Nope.
I've heard that when pen testers encounter like scrypt or bcrypt, they just give up. They say attack a different way. Can you force Windows to use those methods? I don't really know much about them.
Unfortunately not. The reason for this is because of the way Kerberos operates, they need some kind of static key to initialize everything, and if you have a salted password, you're not going to have your Kerberos actually function, especially like their Microsoft's version of MIT Kerberos. The best I could see them doing, and this is my humble opinion, so I could be completely ass wrong, is they could do something like a SHA-512 unsalted for the back end, but there's so much of the Windows core that's built around NTLM that they'd be changing this stuff for years, and by the time they did their changes, we'd be 20 years from now and still dealing with compatibility issues. It took us 10 years to get rid of Landman.
So they're not currently salting?
Not even remotely. Not even remotely. That's why they use challenge response. Like that's why Landman or NTLM version 1 came out and version 2 came out. So they could do an exchange with modified client challenges. So when you modify the client challenge or the server challenges, it's what kind of masks or gives like a one-time component to the exchange, so you're not directly communicating the NTLM key. Because once you get that key, it's game over. That's why pass the hash is so effective, because you can go generate, if you have an NTLM hash, you can go generate an AES Kerberos ticket and just walk around the network using existing tooling. Because you create the key. Everything is based on the NTLM hash. You have that, you own it. Which is oddly enough why we recommend people change their Kerberos ticket hash twice a year. Because if you don't, you can forge tickets all day long after every time your sysadmins leave.
Okay, so those DES keys that you discover, are they, number one, are they domain specific, server specific, and are they reused?
That hash would work across every environment. So basically the DES keys that are in there for, and if you want to go more detail into the research, the guy who did some of the original research was Moxie Marlinspike. It's all based off his paper. The des keys are effectively generated off the NTLM hash. So you take your NTLM hash, you split it into 3 different chunks, you run des across it, and that's it. So it's purely based, it's same across every domain.
So they're user specific.
The user specific, right down to their password. Now, if you have 2 users with the same NTLM hash, then their keys will be, and say somehow they have the same NTLM challenge, those will be the same. But if the client challenge changes or SSP is involved, then they won't look the same. That's why you can't do a direct lookup. But if the client challenge is the same, you're using --LM, they'll show up the exact same every time. Anybody else? Bueller? Sure.
I know this has absolutely nothing to do with it. What is your recommended learning path for Kerberos? All the reference materials I've seen stop off in like 2004.
You know, and that's all the reference materials I've seen as well. Thing is, Kerberos was built 20 years ago-ish, and then Microsoft modified their variant of it. And because it's a standard that you can't really mess with too much because everything speaks it now, you don't really have much option to harden it. I mean, there's Kerberos armoring now that came out in Server 2016. There are the use of AES keys that have MD5 HMAC keys now that are making things a lot better. So it's really, there's a good heavy hardening guide. That's the best I can tell you. It's an arms race. No matter what you try, we're always going to get in. It's just how long you're going to keep us out. I know it sounds like I hate on Microsoft a lot, because I actually do like Microsoft. It's just some things are more annoying than others. Anybody else? Bueller? Cool. God help me when this camera feed comes out and a certain person comes to go yell at me, but that's all right. Twitter should be fun. Thank you, everybody.
Thank you.